This is page 155, problem number 14. The first thing you want to do with this is integration by parts, but first thing you want to do is simplify it by substituting in y for 2x. Therefore dy will equal 2x. Substitute that back in, you get y secant squared y dy. Y is 2x, dy is equal to 2 dx. So this takes care of the missing 2 there. So using integration by parts, you can have y tangent y minus the integral of tangent y dy. Because the derivative of u is 1. So it's y tangent y, take the integral of that as natural log of secant y plus c, and then you have to go back and substitute in the values. 2x, right, tangent 2x, natural log of secant 2x plus c. All right, page 168, number 12. You want to use this diagram that's on page 164. Try substituting it in, see how you do with it. Pause the video, and I will do the work on the board. Okay, the first step here is to realize that x is equal to y, a is equal to 5. So this is y squared minus 5 squared. Therefore, the secant of this is going to be y over 5 equals the secant, which means y is equal to 5 secant theta. dy will be equal to 5 secant theta tangent theta d theta. Okay, pause the video, keep trying. All right, so according to the information on page 164, square root of y squared minus 25 is equal to 5 times the absolute value of tangent theta. So you plug that in for the square root of y squared minus 25. dy is equal to 5 secant theta tangent theta d theta. So you put that in for dy. Y cubed, y is equal to 5 secant theta. So y cubed is equal to 125 secant, should be cubed, theta. All right, so pause the video again and try to simplify that. All right, so tangent of theta is equal to sine of theta over cosine of theta. So tangent squared theta is equal to sine squared theta over cosine squared theta. And that should have line through it. So the cosine thetas will cancel and you'll end up with sine theta. Now there's an integral formula for that. Take a look at your integral formulas and see what you can find. All right. So we brought this down to sine squared theta. If you look in your integral formulas, you'll find you'll get 1/5 parentheses 1/2 parentheses theta, should say bracket, minus sine of theta cosine of theta parentheses plus c. Theta is, secant of theta is equal to y divided by 5. All right, which means that theta is equal to the inverse of secant y divided by 5. And then you have sine of theta. Well, the sine of theta here, well, actually, let me do the cosine first. Cosine of theta is going to be 5 over y here. So that's taking care of the cosine of y. Then the sine of theta is going to be the radical over y, all right, plus c. All right, try number 14, page 168, and that's page 164, not 154. took this formula off page 164. You want to use that for this problem here. Try to set it up. Pause the video. Try to set it up. All right, for this problem, A is going to be 1. X is going to be designated as x is the hypotenuse. The side opposite is the square root of x squared minus a squared, Pythagorean theorem. X will equal a times the secant of theta. A is 1, secant of theta. The x is going to equal secant of theta times tangent of theta d theta. And the square root of x squared minus 1 will equal the tangent of theta. So again, pause the video, see if you can plug it in to its appropriate place. Okay, after you simplify this, canceling secant of secant squared theta, tangents will cancel d theta of the 2. Make this into cosine square. This is the inverse. Cosine square theta d theta with the 2 outside. And the derivative of this will be 1/2 of this. So 2 times 1/2 gives you 1. You have theta plus sine of theta plus cosine of theta plus c. So theta, secant of theta is equal to x over 1. A is 1. So the value of theta is going to be the inverse of x will give you, the inverse of secant x will give you the value of theta. Sine of theta is going to be the side opposite over the hypotenuse, which is square root of x squared minus 1 over x. And the cosine is going to be the adjacent side over x. A is equal to 1, so it's 1 over x. All right. Try number 16. All right, I'm sorry, I left the wrong diagram up there. That's the one you should be using for this problem. So x is equal to 2 tangent theta, and dx will be equal to 2 secant squared theta d theta. 4 plus x squared is going to be equal to 4 secant squared theta. The tangent of theta, theta is here, is going to be equal to x over a, so x is equal to 2 tangent of theta. All right, take the derivative of that. Now the 4 plus x squared, if you square this, you end up getting 4 secant squared theta. A would be 2, so when you square 2, you're going to get 4. You integrate this, you're going to get, after you cancel out, you get 2, the integral of tangent squared theta d theta, which will give you 2, the integral of secant squared theta minus 1 d theta. Now you can break that up into 2 segments. You're going to get 2, the integral of secant squared theta, and I should put a line through there, minus 2 times the integral of d theta. This will give you tangent theta times 2 minus 2 theta plus c. So tangent theta is 2 tangent theta is equal to x. You put the x in there. And then a negative 2 theta is going to be the inverse, 2 times the inverse of x over 2. All right, this is number 18, which was done on the MIT video. And you're going to use from page 164, this is what you're going to use. A is going to equal 1, so x is equal to a times tangent theta, which means x is equal to tangent of theta. And then the radical is going to be equal to a times the absolute value of theta, which means it's going to be equal to secant theta. So try plugging it in, pause the video, see how you do with it. All right. dx is equal to secant squared theta d theta, so I put that in the numerator. X squared, well, x is equal to tangent of theta, so x squared is equal to tangent squared theta. We've already designated square root of x squared plus 1 equals secant of theta, so I substitute those in. All right, go ahead and simplify that. Pause the video, see how you do with it. All right, secant of theta is equal to 1 over cosine of theta. Tangent squared theta is equal to sine theta, sine squared theta over cosine squared theta. You simplify that, you'll end up with cosine theta over sine squared theta. Now what you want to do is substitute in a u for one of the terms. See if you can figure out which one. Pause the video. All right, so let u equals sine of theta, du equals cosine theta d theta, should be. Substitute it in, we're going to have 1 over u squared d theta minus 1 over u after I integrate it plus c, and u is equal to sine over theta plus c, and 1 over sine of theta is equal to cosecant of theta plus c, so it's a minus cosecant theta plus c. So I go back up here and I look at it and say, what is cosecant? Well, the sine would be x over this. The cosecant is the inverse, so it's going to be square root of 1 plus x squared over x plus c. All right, I wanted to do one more, but I won't have enough time on the video. So homework is the handout I sent you, page 155, 13, 14, and 25, page 165, numbers 11 through 15. You have number 19. Now you can look at the solutions manual if you have difficulty with any of the odd-numbered problems. I urge you to do that. Give them a try. If you can't do them, study it from the solutions manual. Go back and do it. Close the manual and go back and try it again. Have a great weekend.